Hi, Jill Baldwin here, with some instruction for the guided practice assignment this week for one-step equations, addition and subtraction. The assignment asks you to follow along with a couple of examples and then complete some on your own, and then to make sure to share your Google Doc by putting the link in the online text in our Moodle course page. Before we jump into the problems, I want to explain the format a little bit. You'll notice that each question is in a table, with the equation on the left side and the word justification on the right. In mathematics, there's many ways to solve any problem. Math is a very creative subject, and every one of us could see a problem and approach it from a different path. And this is totally okay. In fact, it's amazing. The only thing that we need to be careful is that every step we take is justified. Whether it's using a theorem, a definition, or just sound mathematical logic, we need to be able to justify each step in order to prove that our method is a sound method for solving a problem. So we're beginning that work today on one-step equations. We're only going to have one step and one justification, but it gives us a chance to get started into this idea of justifying our actions. So follow along with me for these first two examples, and then you can complete the rest of the assignment on your own. Our first question here, x plus 7 equals 4. So whenever we're solving equations, we always want to start by asking ourselves what operation is being done. And right now, 7 is being added to our x. So we want to do the opposite thing. The inverse operation of addition is subtraction. So we are going to subtract 7 from our variable. Whatever we do to one side of the equation, we have to do to the other side. That's that property of equality that says if something's equal, both sides are the same. So if we do something to one side, we have to do it to the other side to keep our equation equal. Since we subtract 7 from the left side, we're going to do the same thing to the right side. That is a property of equality. And specifically what happened was we subtracted. So our justification is the subtraction property of equality. We got our first step and we got our justification, but we're not finished with the problem yet. Let's actually finish the mathematics. On the left side, if we look straight up and down, our x can come straight down here. Positive 7 and a negative 7 are inverse operations of each other. They're opposites. So when we do those two operations, they cancel out and just equal 0. So we're just left with x on the left side of the equal sign, which is fabulous because that is the goal of this. On the right side, we have a little bit of math to do. 4 minus 7. 4 is a positive number. 7 minus 7 means to move 7 spaces to the left on our number line. So we're going to end up with negative 3 as our solution. It's always a good practice to check your answer in the original equation, and we do that by plugging in the value we found in for the variable. So instead of x plus 7 equals 4, we're going to have negative 3 plus 7 equals 4. And if you do that math, negative 3 plus 7 indeed is 4, so we have checked our answer and it is correct. I have one more problem to do here that I'm going to do with you, and then you'll have some that you'll get to do on your own as well. K minus 1/4 equals 3/4. So this time, what's being done to our variable is 1/4 is being subtracted. So our inverse or opposite operation is going to be addition. And since 1/4 is what was being subtracted, we are going to add 1/4. And remember, whatever you do to one side of the equal sign, you have to do the other side to keep everything equal. And what we did that was equal to both sides was we added. So our justification is the addition property of equality. All right, let's do this adding. Again, we're going to go vertically. We'll start with k. There's nothing to add to the k, so it just comes straight down. Negative 1/4 and positive 1/4, those are inverse operations of each other. They're opposites. So when we add them together, they just cancel out and equal 0. Our equal sign comes straight down, And then we have a little bit of fractions to do here. 3/4 plus 1/4. These fractions have common denominators. So when we have common denominators, the denominator remains the same, and we add the numerators. And this time we have 3 plus 1, which equals 4. And we end up with k equals 4 over 4. And 4 over 4 can simplify. It just equals 1. So k equals 1 is our solution. Again, it's always a good idea to check our answer. And because I have my pen here, I kind of ran out of space in my table, so I'm going to write it down below. 1 minus 1/4 equals 3/4. If we change 1 back to a fraction, we want it to have a common denominator with our other fractions, which would be 4. And 4 times 1 gives us 4 for the numerator as well. 4/4 is the same thing as 1, which we did see earlier in the problem. And 4/4 minus 1/4, denominator stays the same, and we subtract the numerators. 4 minus 1 is 3. So it did in fact work. I'm aware that you might not be able to use a pen on your Google Doc. Please feel free to type your solutions. I also applaud creativity, so if you have a different way to type your answers in or input your answers, then please, by all means, give them to me. I'd love to see you do a screencast or any other method. You guys know a lot of tools, so I'd love to see your creativity. All right, good luck with the rest of the assignment, and please let me know if you have any questions.